this rare binary system could help us understand how stars form. But also, this star is like 18 times brighter than our sun and is right now. But that's not all. For this star, I captured 2 different images. But what is this star? This star is haze, also known as Zeta Virginis. These 2 images were captured with the C-Star S50, a popular smart telescope. The C-Star currently does a lot of actions in the background, such as removing background noise and shooting in 4K. One of the main headlight features is AI denoise. I know AI, we don't like AI, but this AI is actually good. And so the result of that is shown to the image on the right, and then all the other stuff, not the AI denoise, just other features, is shown to the left. As expected, the image is high quality but a bit boring. The main star in the center and just a couple other stars around. But that's not all. Data analysis. Pretty simple. Symbiote, Wikipedia, etc. Just general data about this object. First, we have that it's about 22.859 parsecs from us. Parsecs are a pretty standard unit of measurement and roughly 3.2 light years. 1 light year is how fast light travels in 1 year. The star is thus about 73.8 to 74.4 light years from us. It is also moving toward us anywhere from 13.2 to 15.2 to 11.6 kilometers from us. Those are generally the ranges I saw in the data. Let's go with 13.2 because 2 of the measurements with 13.2 give a margin of error of 2 and 2.6 respectively. And so those margins of errors can apply to all the measurements found. Next, the star is spinning at 222 kilometers per second, which is extremely fast. It will literally spin 1 full rotation in 0.5 days. Yes, it is crazy. Parallax is used to calculate distance. For this star, it's about 44.03, margin of error 0.19, and the apparent magnitude is 3.376, absolute magnitude 1.59 to 1.69. This absolute magnitude range is obviously using a margin of error calculated with the different electromagnetic spectrums. So there's K, H, and J measurements. Those are for near infrared, EPP, blue photometers, and GRP, red photometer, and then G, which is white light. These are for European Space Agency's Gaia telescope. And then the general numbers, so U for ultraviolet, B for blue, V for visible light, red for R represents red, and then I for infrared. Oh, we also have more color indexes. UB and BV are color indexes for the color of the star to calculate temperature. It's 0.41 and 0.114 respectively, which puts this star at about an A3V spectral class, which is true. This star is about 8,300 Kelvin, which is a unit of measurement a bit better than Fahrenheit or Celsius for temperature measurement and astronomy, and about 2 suns with a radius and mass, 18 times the brightness of the sun at 500 million years old. The iron to hydrogen ratio measurements are different, some about 55%, some at 78%, some at 100% of the sun's, metallicity. So you can do your own interpretation, just like with literally anything else said in this video, which I'll put the sources for in the end so you can check them out. Now, the big mystery. Basically, this chapter I just tell you the cool thing about this object. Now, there's a faint red object around the star that orbits the star about every 124 years. Another thing is that it was discovered that this object has an apparent magnitude of about 10.3, so it should be pretty bright, I guess. The second object is about 24.9 times further from haze than the Earth is from the Sun. This relationship between haze and the second space object, and in general some relationships, are used to understand X-rays and how these stars form. So what is this object? It is a small red dwarf that orbits the main star haze. It's a binary. Those are very common. The small red dwarf has a mass of about 0.168 plus 0.012 minus 0.016 solar masses. This means that the red dwarf is just 0.082 plus 0.007 minus 0.008 times the mass of haze. This type of much lower mass star orbiting a bigger star would be normal if haze was the same mass as the sun, but it's about 2 times the mass of the sun. So the system is rare. Haze is also like the 4th brightest star to us in the Virgo cluster. Its actual absolute magnitude is only like the 6th actual brightest. Oh, and its RA is like 13 hours, 34 minutes, 41.591 seconds, minus 280.48 milliarc seconds per year. Margin of error 0.17. And its declination is negative 35 arc minutes, 44.95 arc seconds. No degree. Overall moving 49.05 milliarc seconds. The margin of error is about 0.12. This in turn means that this object is really close to like the equator. Not like actually close to the equator, but like it's in like a very similar line to the equator. It's not too much up, too much down at all. Okay, chat, here's the cooked timeline situation. By the way, this is a pretty beginner timeline, alright? I swear. Oh yeah, and also, check the Google Drive link in the description. Is basically so you can see all my astronomy photos, because it's like, cool, I don't know, just see them in higher quality. Here are the sources I used. Here's an external image. Pause the video, and yeah, bye.